Here on Weather World, we spend 15 minutes each night talking to you about the weather. You can think of the weather as an impulsive teenager with a short attention span, prone to extreme behavior at times. It will act out, but forget about it quickly and tend to move on. Weather is like a mood. Now 30 years have gone by. That once impulsive teenager is now an adult, still impulsive at times, still sensitive to the environment, and can spend months at a time interacting with influential friends such as El Nino or La Nina. This adult we think of as climate. Climate is not like a mood, but instead a personality, with the day-to-day weather being its wide variety of moods. As research continues and gets better, it has become clear that our sensitive adult, the climate, has been getting itself into strange situations more frequently. The drivers of its individual days are similar, but the overall trajectory has changed a bit. As meteorologists and atmospheric scientists, it is our job to provide you with the facts. For the next few weeks, my goal is to help provide you with the science, the facts, regarding our climate, which is undergoing some change, and things we can all do to help protect Mother Earth. And I want to begin with a science lesson.
The center of the Earth is really hot, but we don't burn our feet. It can be hot and cooler because the rocks slow down the transfer of energy. The pot on the stove is hot and you can grab it without burning your hand because the oven mitt slows down the transfer of energy. Fourier, in 1829, did the energy balance for the surface of the Earth and said, wow, it's a little hotter than it should be because something is slowing down the transfer of energy. It must be gases in the atmosphere.
Dr. Richard Alley is a world-renowned geoscientist and glaciologist here at Penn State. Research that he has done on a daily basis has helped us to reconstruct the historical record of what the climate was like. Much further back than weather record keeping began in the late 1800s, we are talking hundreds of thousands of years. Ice can tell quite a story.
And I've been to Greenland 9 times and Antarctica 4 times, and Greenland and Antarctica are these giant piles of old snow squeezed to ice, and they're sort of 2 miles thick and a continent wide, and they sit there and spread under their own weight, and locked in them is the history of what was in the air and of the air in bubbles that's piled up over hundreds of thousands of years. And I've been involved with going there, and you drilled down and brought up a piece of ice, and you go get another one, and you go get another one, and you go get another one, and you do that for a few years. You get a 2-mile-long piece of ice with history written in it.
So when you are looking at tens of millions, hundreds of millions of years in the past or in the future, the climate absolutely, it goes up and down. And we have fairly good idea of why those have happened, either massive volcanic events, changes in the Earth's orbit, even some changes in the sun, and they all impact, of course, our climate. Science understands that. Science also understands how you get warmer and how you get colder, even if you don't change the sun. And it turns out that these greenhouse gases, and basically they trap heat down near the surface where we all live.
This phenomenon is known as the greenhouse effect, and to be clear, the greenhouse effect is essential for maintaining life on the planet as we know it. In fact, if you average the annual temperature over the whole planet, it comes out to be around 15 degrees Celsius or 59 degrees Fahrenheit. Without the greenhouse effect, Earth's average temperature would be about negative 18 degrees Celsius. That's 0 degrees Fahrenheit, much harder to sustain the life we have come to know. So how does it work? Solar energy absorbed at the Earth's surface is radiated back into the atmosphere as heat. As this heat makes its way through the atmosphere on its way back out to space, greenhouse gases absorb much of it. These gases are more complex than other molecules in the atmosphere, with structures that can absorb heat more easily. They can transfer that heat energy to neighboring molecules and can in turn then radiate that heat back toward the Earth's surface. And if you go back to some of the research that Dr. Richard Alley has done, deep within the ice, you can see that the Earth's climate in the past has not made many moves without CO2.
I had the experience when I was an undergrad of collecting fern fossils from Mount Flora on the Antarctic Peninsula. So you're in Antarctica, it's snow everywhere, and you pull out this beautiful fern fossil from the Jurassic. And there's two chances. One is the continent was somewhere else, and in this case, it wasn't that far from where it is now. And the other possibility is the climate changed. And so geologists sorted this out a long time ago, that the Earth's climate is changeable. And so immediately as a geologist, you're sitting here saying, this is something that can change. And then geologists, climate scientists, all of us got together and said, what is it that changed the climate in the past? And there's a whole bunch of things. But it turns out that CO2 has been more powerful in changing past climates than anything else has.
And we've been putting these into the atmosphere for about 150 years or so at pretty significant quantities. So we are in some ways driving the climate now much more.
Science can tell us quite a bit about where we've come from. It can also tell us quite a bit about where we're going. We'll talk about that next week. For Weather World, I'm Ben Reber.